Hey, welcome back. No umbrellas this time. Part 3 of the heart. But we're going to pick up right where we left off because I was in the middle of doing my, special effect umbrella analogy. And what it made me think of is that I actually need to give you a better explanation of why blood moves through the heart in a particular way. And it has to do with something that I want to lay the groundwork for now in anatomy that you will really benefit from knowing when you get to physiology, and then that will inform pathophys, and that'll inform your clinical knowledge when you get into nursing corps. So what I'm going to do is I'm going to jump back to where we were sort of at the end of the last lecture when I was talking about the valves, and we were talking about blood flowing through the heart. So let's get back to these pictures, right? And remember, we were taking this tour through the heart, and then at the last piece of this, we were talking about not just the structures, but the differences in how in the sides, and then how the blood flows through the heart. So we talked about the valves, that's shown here. Remember, the AV open together, the semilunar open together, and they AV and semilunar open at different times because the top of the heart contracts before the bottom of the heart contracts. That's really important. If you look at this slide right here, it talks about the function of the valves, something called the cardiac cycle. Cardiac cycle is just a single set of an entire heartbeat, which means all four chambers have gone through a contraction phase, which on ground this week, in the classroom, we talk about as systole and diastole. So systole is the contraction. Diastole is a single cycle of relaxation. So it's an entire heartbeat. That's the cardiac cycle. Okay, so that feeds back into what we ended with last time, talking about how blood goes from the atrium into the ventricle, how that causes then the valves to shut when the ventricle contracts. But I think you need more explanation on this, because when I was a student, I was trying to understand how is it that blood flows in a particular direction. And it has to do with some simple ideas that I want to introduce to you. And this has to do with pressure. So the heart and its different chambers, by squeezing those chambers at different times, at going through atrial systole and then ventricle systole or ventricular systole, is basically changing the pressure in different chambers at different times. So I don't have any animation on this PowerPoint, and I can't draw on it like I would in the classroom on the board. So instead, we're going to get old school, super old school, and I drew a diagram of the heart on a piece of paper. Whoa, check it out. Special effects. All right, so this is just a simple line drawing of the inside of the heart. You can see I've got the four chambers. I made the atria a little bit bigger just so you could see them. RA is right atrium, LA is left atrium, RV right ventricle, LV left ventricle. Okay, this is going to help me as I want to explain to you just quick and dirty 5 minutes on how blood flows through the heart. It's actually a principle in all of nature, and you'll learn a lot about in physiology. But I have a way that I simplify it that makes it easier for me. There is this idea in all of biology that when things, substances, heat, pressure, volume, is at a higher concentration in one place and at a lower concentration in another place, that what will always happen is that whatever the substance is or the energy or whatever, wherever it's higher concentrated, it will always want to flow to where it's less concentrated. So whenever you have, let's just talk about different pressures, right? Whenever you have two chambers of the heart and there's a lower pressure, well, let's do like this because I kind of set it up this way. Let's say it's a higher pressure over here, okay? And there's a higher pressure in this chamber and a lower pressure in this chamber, then it's that difference in pressures that causes the blood to flow. So the reason that blood flows from one chamber to the next is because the pressure is higher in one spot, lower in the other spot, and it always flows from high to low. So I have this phrase that I always teach all my physiology students when I'm teaching physiology. I always say, from high to low is the flow. I like it, and I made it up because it rhymes. And for me, if it rhymes, I'm going to remember it better. From high to low is the flow. So how do we apply that? Okay, check it out. Here's my heart. My fancy heart drawing. So how does blood flow through the heart? Well, blood has to be at higher pressure in one chamber and in lower pressure in another chamber for it actually to flow. How does that actually work? Let's just walk through the cardiac cycle through one quick cycling, okay? Give me 1 second. Okay, so let's say I have blood flowing initially into my heart into the right atrium from the body, from the systemic circuit, right? So as that blood flows in, it's beginning to fill up the right atrium, and some of it's going into the right ventricle too, but it's filling up that right atrium. As it fills up that right atrium more and more, it starts to push up against the walls of the right atrium. And then the right atrium, in response to that fill, is going to go through systole. It's going to contract. It's going to contract here on the right atrium. When that happens, you're going to squeeze that blood. So I'm going to draw these little lines representing the atrium is squeezing. Look at it. It's squeezing, right? And as it squeezes, what do you think that does to the pressure of the blood in the right atrium? What do you think? What do you think happens? If I squeeze the blood in the right atrium, will the pressure go up or down? That's right. It will go up. So the pressure will go up. So I'm going to draw the letter P, and I'm going to put an arrow showing the pressure just went up. Now as the atrium begins to squeeze, and the more it squeezes, the more the pressure will increase. So I will put another arrow, and so now the pressure is really going up. Up. Well, the pressure is going to go up so much that the pressure is actually greater in the right atrium than it is in the right ventricles. The right ventricle is not squeezing. The right ventricle, well, it's got some pressure in it, but that pressure is a lot lower than the right atrium. So the right atrium is a higher pressure than the right ventricle. So this is higher up here, it's lower down here. And what was the phrase I taught you? From high to low is the flow. High, low, and therefore this is the direction of the flow. And that's why when the right atrium squeezes, it delivers blood into the right ventricle. From high to low is the flow. Makes sense, right? Well, what happens next when the atria relaxes and the ventricle starts to squeeze? That might get a little more interesting. Let's check that out. Okay, so now we have, just a few moments later, blood has gone into that right ventricle, and that right ventricle is filling up with blood. You see all this blood coming in? And then the right ventricle begins to squeeze. The atria relaxes, and the atrium relaxes, and the ventricle begins to squeeze. So we get massive squeezing because the ventricles are so much bigger than the atria, right? So we are getting squeezing all across the side of that muscle of the right ventricle, and as it squeezes, as it puts the pressure on, it squeezes that blood, and so look, the pressure is going up. In fact, as it squeezes, the pressure is going to go so high because it's a ventricle, and the thicker the muscle, the bigger the muscle, the more the squeeze, the more the pressure. So I'm going to draw lots of arrows. Look at that. Oh man, that pressure is going up. So that's a lot higher than here, right? Because now that right atrium is relaxed, so the pressure is relatively low in the right atrium. High, low. Uh-oh, from high to low is the flow, right? So this should flow back. It would if there wasn't a valve. That's why you need valves. Because what you need is a valve, shown here by these two cusps, that when the blood starts to go up, it catches under these little pockets. Remember my umbrella example? Catches here and it catches here. And that blood pushing up on the valve is what closes it shut. The valve goes shut, like that, slam shut. And now, even though it's higher pressure here, lower pressure here, high to low, but you don't allow for flow because the valve blocks. So what's going to happen? So the blood can't go anywhere? It's just going to keep getting squeezed? The pressure's going to go up? No. This is why you have big arteries coming out of each of the ventricles. In the case of the right, we're talking about the pulmonary trunk. And I'll just draw that on top here so that you can see it. So here's that pulmonary trunk, kind of exaggerated, but there's the pulmonary trunk coming out. And up here in the pulmonary trunk, the muscle's not squeezing. There's no muscle squeezing up here. All the squeezing, whoops, is happening down here. So the pressure's going up, 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 right? I'm trying to do everything backwards. There we go. The pressure's going up. And that means the pressure is lower. See that P up here? It's lower up in the pulmonary trunk, higher down here. From high to low is the flow. And that's why blood flows out the pulmonary trunk. So it's the combination of this idea that you create a higher pressure and you have a lower pressure that allows for flow, plus the idea that you have one-way valves that shut and don't allow the blood to flow backwards even if it wants to, that allows the heart to have unidirectional blood flow and allows the entire system to circulate in one direction through both the systemic and the pulmonary circuits. That's sort of the quick, fast, dirty example of how blood flows and how it's all based on pressure gradients. And it's all high to low is the flow with pressure. By the way, you'll learn as you get further on in your career that it's not just pressure. That's true for heat. That's why on a cold day when you go outside, the hotter your body is and the colder the environment, the more the flow of heat out of your body. If you're hot, you have a high temperature, higher the high. And if it's cold outside on a cold, chilly morning, temperature's low, the lower the low, the more the flow. And so you're at more risk of losing your body heat and shivering and going hypothermic on a day where there's a bigger difference between your body temp and the outside body temp. I know that's off topic, but it's really cool, right? This is why I love physiology. I have such a passion for it because I think it's so cool. It describes so much. So just remember, from high to low is the flow. Okay. Oh. Trademark Kolb. From high to low is the flow. Okay, moving on. Thanks for putting up with me. All right, I just love that stuff so much. It's really cool. All right, so the last thing I want to talk about in this lecture that is not talked about on ground this week in class is the anatomy of the blood vessels that actually supply the heart muscle itself with oxygen and with blood in general, and then also are going to be draining that blood away. So these are the coronary arteries bringing blood into the heart muscle, and the cardiac veins that are taking the blood out of the heart muscle. So the coronary arteries, they actually come out of the aorta. They're the very first branches out of the aorta, which means that the heart actually gets blood supply for itself first before any other organ. Because as the aorta is coming out, there's these two little branches that come off and supply the heart muscle. These two blood vessels that come out and supply the heart are called the coronary arteries. There's one on the right, one on the left. So they are the right coronary artery and the left coronary artery, or RCA and LCA in abbreviation. Let me show you a picture of this. Here's the front of the heart with everything kind of faded to the background except for the coronary arteries and cardiac veins. Can you see that aorta coming up and the aortic arch at the top? And notice at the very base of the aorta, there's a right coronary artery in red coming out, going to the right side, and there's a left coronary artery coming out and going to the left side. So you need to know those two big arteries, the RCA, right coronary artery, and the LCA, left coronary artery. Now they have lots of branches, each of them, but we're just, for our purposes, going to know two main branches from the RCA and two main branches from the LCA. Let's take a look back and see what those are first before I show them. The two branches of the RCA are the marginal artery, or the right marginal branch, and the other one is the artery that runs down the back of the heart. It's called the posterior interventricular artery or branch. That name might sound familiar to you from the previous online lectures on heart, because at the very beginning I talked about this groove that goes down the front of the heart and a groove that goes down the back of the heart. They were called the anterior interventricular sulcus and the posterior interventricular sulcus. Each one of those has an artery running down it. So in the back, the posterior interventricular artery runs down the back of the heart. So if you flip it around, here's the posterior side of the heart. Can you see, if you look up at this diagram, if you look at the right side of the diagram, you'll see the right atrium, right ventricle. You'll see that there is a blood vessel going vertical down the back of the heart. And if you look at its label, which is kind of at the bottom of the drawing, it says posterior interventricular branch of the RCA. So that's the first branch of the RCA. The marginal branch, that you can actually see pretty well here too. That's kind of coming around the back too. Do you see the right marginal branch down at the bottom of the drawing, kind of over to the side of the heart? Do you see that? Kind of all the way to the right, on the right side. So that's the right marginal branch, and then you have the posterior interventricular branch. Two big branches of the RCA. If I flip it back to the front, you can actually see the marginal branch as well from this view. It's the one that's going along the bottom on the right side, the right of the heart here. So anyway, find those two branches. That's for the RCA. For the LCA, the two branches are called the circumflex branch and the anterior interventricular branch, which runs down that groove on the front of the heart. So again, here's the picture. Find the LCA at the top, and notice that part of the LCA curves around the back of the heart. That's the circumflex, so it's in circles around the back of the heart. And the anterior interventricular branch goes right down the front. Do you see that? Separating the right and left ventricle. So those are the two branches for the RCA and the LCA. And that's all you need to know for the arteries. Oh, well, I should say, welcome to medicine. Unfortunately, two of these have different names that can also be used, especially in cardiology. They will sometimes, or they're not sometimes, a lot of the time they're going to use these names. So if you look, let's stay at the back of the heart here. If you look at that posterior interventricular branch, right, that branch of the RCA that you saw here, it goes by another name. It's also called the posterior descending artery, or PDA. You'll see this charted or written on angiograms sometimes, you know, slight occlusion of the PDA. So you will see this PDA, or posterior descending artery, especially in cardiology, they'll use that term. If you flip around to the front of the heart, there's also that anterior interventricular branch that also goes by another name, but it's slightly different. It's called the left anterior descending artery, or LAD. So you'll see that charted as well. You know, there's some kind of coronary blockage in the LAD. So just remember there's these alternate names for the two big branches, one that runs down the front and one that runs down the back. Posterior descending is the other name in the back. Left anterior descending is the other name in the front. Because why would they make it simple, right? Right. On the other side of things are the veins. There are a bunch of veins, but I'm just gonna have you know the three big veins that drain blood away from the heart muscle, and they're easy to remember. They are the great cardiac vein, the middle cardiac vein, and the small cardiac vein, and they all drain into this big catch pocket that's on the back of the heart called the coronary sinus. So again, if we look here, here's the front of the heart. You can see the great cardiac vein running down the front. That's collecting blood from the front. And that great cardiac vein, if you flip the heart around, you can see that's circling back around the top of the heart to come towards the back. The middle cardiac vein, you can kind of see that in the middle posterior of the heart, kind of going down that posterior interventricular sulcus. And then the small cardiac vein is coming around the right side between the right atrium and right ventricle, and they're all emptying there at the middle. Do you see right at the middle, that big blue catch pocket? That's the coronary sinus. That collects all the blood and puts it back into the right atrium because it's deoxygenated blood, and you're putting it back into the circulation where all the rest of the deoxygenated blood comes from the body, because that other blood's coming from the superior and inferior vena cava. This is the heart's deoxygenated blood, and it's putting it back into that same circulation. Okay? All right, so those are the cardiac veins, the coronary arteries, and that's the anatomy of the vasculature of the heart that you need to know. And that brings us basically up to speed with where the lecture material starts for this week. And so you should have everything you need now for the heart lecture. So thanks for staying tuned through these three kind of bigger lectures, but the heart's a really cool organ, and there's a lot that you need to understand, and it was important that we got this opportunity to kind of suss it all out. So if you have any questions, let me know. Otherwise, look forward to talking to you again soon. All right, bye guys.